All right, hey chemists, in this next video lecture, we're going to be talking about density graphs and density. So on the graph right here above is the mass versus volume of gold and water. Might be hard to see, but this top graph here is gold, that's in blue, and this bottom graph here is water. Don't forget that water, its slope is 1x. Gold, its slope is 19.3x. This means 19.3 grams for every 1 milliliter. This means 1 gram for every 1 milliliter. So if we look at these two graphs, which slope is more steep? Basically, it's asking which one is a higher graph. The answer will be, of course, gold. It's higher up. Now, what does higher up mean for chemistry? How can this show us that one substance has more mass in a given volume show on the graph? So when I say given volume, how can I show this? Choose a volume, doesn't matter which one, draw a vertical line. The higher graph will have more mass in a given volume. So let's do this for gold and water here. Let us look at, doesn't matter, let's choose 10. Here's 10 milliliters. I'm going to draw a line, vertical line up at 10. Now this is the mass of 10 milliliters of water. This is the mass of 10 milliliters of gold. This one is higher. And clearly this is more mass in a given volume. So gold is higher. That's more mass in a given volume. That is definitely a future quiz or test question to unpack there. We could do it again. Let's just do the 5, right? If I draw a vertical line up at 5 right here, again, this is higher. There's more mass in that given volume of 5 milliliters. So what is this mass to volume relationship called? This is all density. So density is a characteristic quantity of matter. Characteristic means it could be used to identify. That's kind of like our whole little gold necklace challenge thing. So density is a characteristic quantity, meaning it could identify matter, that relates to the amount of matter, which is mass in grams, with the space that matter takes up, which is volume. For us, that's milliliters. The density can be calculated using the equation density is equal to mass divided by volume. So that's grams divided by the milliliters is going to give me density, D. If you want to calculate just volume of a mass from a density, let's say I didn't have something in front of me and I just was trying to figure out its volume. Volume, if I rearrange this equation, volume would be equal to mass divided by density. So if I have a mass in grams and I divide it by a density, that's going to give me a milliliters. Finally, if I wanted to calculate a mass of a volume from a density, density times volume equals your mass. And this we kind of got from, this is what we were doing before. This is kind of like our data. Remember, density was like our slope. Our volume was our x value. That gives us our y value of mass. That's where this came from. So if I take my slope, which is my density, and I multiply it by an x value, I'll get a y value. So for example, if I take my slope, which is, for this one is 19, if I multiply it by an x value, which is 20, so if I do 19.3 times 20, I get my y value, which is close to 400. Let's do some practice here. I'm going to set you up. I'm going to tell you which equations to use, but you're going to do the calculations on your own and then check with me. So we're going to be using these three equations. I'm going to label them as 1, 2, or 3. So question 1 says, if an unknown metal substance has a mass of 40.5 grams and a volume of 15 milliliters, what is its density? You're going to use this equation. If I want to get density, I'm going to take the mass and divide it by the volume. So your mass is your 40.5 and your volume is your 15. Look at question 2. It says, if the density of water is 1 gram per milliliter, what is the volume of 50 grams of water? For this one, if I want to get volume, volume is going to be equal to mass divided by density. And our mass is 50 grams and our density is 1. This is going to give me for number 1, I'm going to get an answer in grams per milliliter. For number 2, I'm going to get an answer in milliliters. And then I don't know if you see where this is going. Number 3, if the volume of a sample of gold is 12.0 milliliters, what is the mass if the density of gold is 19.32 grams per milliliter? So if I want to calculate mass is going to be equal to density, which was given to me as 19.32, times volume. So that means my answer to number 3 is going to be in grams. Then look at the last one here. We can also use the density to identify unknown substances. So using this table, what is the identity of the unknown metal in example 1? So here is example 1. When you go and calculate its density, you could compare it to the table right here. Whichever density it matches is its identity. So if I go and calculate 1 and I'm like, oh, I get a density of 1.74, that means it must be magnesium. Anything will have the same density if it's the same substance. So the density of magnesium will never change. The density of copper will never change. The density of zinc will never change at given properties. So I'd like you to try and do questions 1 through 4 and then check with me.